All right, let's dive right into this explainer and fast forward ourselves to the year 2126. Just imagine waking up, looking out your window, and watching the Earth rise to start a brand new day. You're living in Luna Prime, humanity's absolute first lunar city. And honestly, it sounds like an absolute dream, right? But to truly grasp the thrilling, incredibly high-stakes reality of waking up in a place like this, we really need to understand exactly what we're up against out there.
You know, people often think living off-grid in Antarctica is tough, but hey, at least down there you actually have oxygen to breathe. Up on the moon, it is a whole different level of deadly. Without any atmosphere or magnetosphere to protect you, a sudden solar flare could literally shred your DNA. And don't even get me started on the micrometeorites. These things fly faster than sniper bullets. A single, tiny space rock, traveling at 50 miles a second, can punch right through your oxygen tank or crack your helmet wide open. So yeah, every single outdoor job is incredibly dangerous work.
And honestly, if the space rocks don't get you, the temperatures absolutely will. If you were hanging out near the moon's equator, you'd be dealing with a brutal 14 solid days of darkness every single month. We're talking terrifying temperature swings here. In direct, unfiltered sunshine, it boils right up to 127 degrees Celsius. But the second you step into the shadows, it plunges to a deep freeze of negative 73 degrees. If you've ever tried starting your car at minus 30 in the dead of winter, trust me, this is way, way worse.
So why on Earth, or rather off Earth, would we endure this deadly environment? That brings us to Section 1, the cosmic gateway. And it really all comes down to basic physics and gravity.
Think about it. Escaping Earth's gravity requires a massive amount of fuel weight. To just barely scrape into low Earth orbit today, a rocket has to hit 35,000 kilometers per hour. That means like 90% of a rocket's total weight is pure fuel. But up on the moon, you're walking around in just 16% of Earth's gravity. That makes any launch from the moon a whopping 84% easier. It acts as this wildly efficient, low-cost stepping stone to Mars, the asteroid belt, and way beyond. Without an atmosphere in the way, we could even use railguns powered by electromagnets to literally shoot payloads straight into orbit. How cool is that?
Moving right along to Section 2, the road to 2126. Because to truly appreciate a sprawling metropolis like Luna Prime, we have to look at the astonishing feats of engineering that got us from one small step to a bustling city.
This timeline really compresses decades of staggering progress. Now, we all know 1969, right? Armstrong and Aldrin spending a brief 21 hours in a tiny 8-foot lander. But the real game changer was finding lunar water in the 2000s and 2010s. That totally shifted the narrative from just a quick visit to building a permanent, self-sustaining base. Fast forward to Artemis 2 in 2026, firing up our imaginations again, and by the 2030s, NASA actually had people living part-time in what essentially looked like 4 welded thermoses with bottle caps on top.
Which leads us to Section 3, engineering a lunar city. So the crucial point here is figuring out how humanity scaled up from those 4 welded thermoses to an actual metropolis, without everyone getting taken out by rapid decompression.
Well, it's all about location, location, location. By wisely choosing the Shackleton Crater down on the moon's south pole, NASA solved multiple extreme challenges all at once. First off, the crater ridge offers near-constant sunlight, so you bypass those freezing 14-day blackouts. Second, they can use the deep shadows to safely store those 95-year-old radioactive plutonium heater units that keep the machines from freezing solid. Third, the permanent darkness deep inside the crater preserves all that precious water ice. Plus, as a massive bonus, this specific spot gives us a direct, uninterrupted communication link right back to Earth.
Now, let's talk about the building materials. Lunar regolith is an absolute nightmare. It's incredibly sharp, it's sticky, and it gets into literally every single spacesuit gasket and hinge, which over time can cause deadly air leaks. But, plot twist, despite the mess, it's surprisingly useful. It's actually packed with oxygen, silicone, iron, and aluminum. So it basically became the ultimate raw material for our city's entire architecture.
Because you definitely can't just pitch a tent on the moon. Everything has to be heavily pressurized. So humanity brought in these massive 3D printers and laser tech to turn that annoying moon dirt into incredibly stable, pressurized domes. They use a process kind of like powder bed fusion. Basically, lasers melt the regolith powder down and recrystallize it into this super tough structural ceramic moon concrete. And these domes brilliantly shield the local residents, affectionately known as the loonies, from those deadly solar winds. All right, let's jump into Section 4, powering the base, graphite.
We're going to dive into the technological enabler that keeps the pulse of this massive life support system from just flatlining.
Even with that highly strategic location at the South Pole, massive energy storage is totally non-negotiable. So how does the city ensure the power never, ever drops out during deep crater mining or extreme temperature swings? The answer lies in advanced materials, and there's one specific, surprisingly overlooked mineral doing a tremendous amount of the heavy lifting here.
Graphite is quite literally at the heart of this entire setup. Since it's the largest mineral component by weight in lithium-ion batteries, it manages the massive battery banks that are storing all that solar power. But it goes way further than that. Because graphite is highly conductive, temperature stable, and chemically resilient, it's woven directly into the heat-resistant composites of the habitats themselves. It even stabilizes the AI data centers that are actively managing the city's oxygen and heat levels. It literally takes raw solar energy and turns it into stored life.
And what's really amazing is that this undervalued mineral is powering our future down here on Earth, right now, too. Companies like Nouveau-Mont Graphite, or NMG, are actually leading a green supply chain revolution. They're extracting and refining advanced green graphite using hydropower to keep a super low carbon footprint. Western governments are finally realizing its massive value for energy and defense, with Canada actually securing 30,000 tons a year from NMG. It turns out the complex energy, AI, and manufacturing challenges we're facing on Earth are the exact same ones we have to solve up on the Moon.
Okay, Section 5, the human factor. Let's step away from the machinery for a second because we really have to look at the severe biological and psychological realities of moving humanity off-world. Look, cabin fever in space is incredibly real. Just take a look at the 2011 Mars 500 project. They simulated a 500-day voyage, and while everyone got along at first, by the time the return trip rolled around, the crew had basically isolated themselves entirely. The researchers called it a social ghost ship. Living in tight, highly regulated quarters where a tiny micrometeorite puncture could mean instant death on the other side of the wall, yeah, that isn't for everyone. Mental health and social harmony literally become matters of life and death. Then, of course, there's the whole issue of food. Back in 2026, Astrobotic quoted space shipping costs at around $1.2 million per kilogram. Since you obviously can't FedEx a bag of carrot seeds for $1 million, and walking outside to plow a field is a literal death sentence, scientists had to perfect vertical hydroponics. Safely inside these temperature-controlled domes, under artificial lighting, they successfully grow leafy greens, peas, and even full-cycle rice, just like researchers did up on the Tiangong space station. And it's all completely adapted to low gravity. Speaking of low gravity, human bodies simply did not evolve for it. So to combat the crazy amount of health problems it causes, Luna Prime uses massive spinning centrifuges for exercise gyms and living spaces. According to a 2015 NASA study, if you want to comfortably simulate Earth's gravity without causing intense nausea every single time you bend over, you need a centrifuge diameter of about 1.5 kilometers, spinning at roughly 1 revolution per minute. It is a massive feat of engineering, for sure, but entirely necessary if you want to keep the loonies healthy. But you know, despite all of these wild hardships, the constant danger, the intense isolation, spinning and artificial gravity, there are moments of just profound beauty. Because the moon lacks an atmosphere, there is no visual difference between night and day. The sky is always this crystal clear, deep, starry black. And since the moon is tidally locked, you can step out, look up from Luna Prime, and always see Earth just hanging there in the sky. It's a constant, stunning reminder of the cooperative international effort that actually brought humanity together to survive in this precarious environment.
Seeing the lights of Luna Prime shining down from Earth fundamentally changes our perspective on everything. The Artemis missions were our tipping point, proving we could actually build this incredible lunar gateway. And that leaves us with one final, awe-inspiring question about our future. If we can survive and even thrive in the absolute most lethal environment humans have ever faced, how long until we conquer Mars, expand across the stars, and finally become a true Type 3 civilization? It's definitely something to think about the next time you look up at the moon. Thanks so much for joining me on this explainer, and keep your eyes on the stars.